So in this video too about estimation, we're going to talk about estimating the population mean when you don't know the population standard deviation. And we're going to use this table called Students' T-Table to do this. And it was created by this guy named W.S. Gossett, who worked for a company where he was not allowed to publish his own work. And so he published his table, the Students' T-Table, under the pseudonym Student. So W.S. Gossett is actually the one that created that table, and it was actually an interesting story if you want to look more into that. But anyway, our formulas look very similar. We still are going to create confidence intervals and all that kind of stuff, but our formulas we have to mess with is just a hair different. Let's jump up here to the formula. So we've got this TC. It's a critical T value that we put in there instead of a critical Z value. All right, so let's go back here. So suppose an archaeologist discovers only 7 fossil skeletons from a previously unknown species of miniature horse. Reconstruction of the skeleton of these 7 miniature horses show that the shoulder height in centimeters to be these values right here. Find a 99% confidence interval for the mean and the shoulder height of the entire population of such horses. All right, so here's the issue that we have with this. We don't know anything about the entire population. We've just discovered these fossils. We've only got 7 of them. We can find the average, the mean of these 7 heights, as well as the standard deviation of these 7 heights, but there's no way to know anything about the population, but we can estimate what we do know about the population. And that's where the confidence interval comes in. So we can say with 99% certainty that the population mean would fall within this range. So we'll come back to this problem here to actually solve this. So like I said, in most cases, researchers are going to have to estimate using the sample standard deviation because we don't know enough to be able to do the population standard deviation. And it's going to follow the new distribution of Students' T distribution, which you'll see here. So it still has the normal-like curve, but it is involved with something called degree of freedom. So our degree of freedom is n minus 1. So it's our sample size minus 1. And the larger the degree of freedom, the closer to standard normal curve it approaches, which you can actually see down here in number 4. And we talked about that when we talked about probability. The more trials you run, the closer to theoretical probability that the experimental probability will get. So the more samples we have, the closer to normal distribution we'll have. But that is an important formula. Our degree of freedom is n minus 1, so make sure you hang on to that formula. Students' T-table does look like this. So I'm going to pull a bigger one over so we can kind of see a little bit better. So this is Students' T-table. This is what is located in a lot of textbooks for statistics. We ignore these first 2 rows, the 1-tail area and the 2-tail area. That comes later and messes with something else. But this DF, this is our degree of freedom going down the side. And then the C is our confidence level. So we could have 50% confidence, 75, all the way up to 99.9% confidence. Now notice as we get further down here, once we hit 30, we start going a little bit bigger. Because we don't have a table that would show that depth of degree of freedom, you would actually do like n minus 1, and let's say you got 32. You would go to the next one without going over. So we'd go down to this row of 30 to actually find our degree of freedom. So let's do an example. Let's say our sample size was 6 and we wanted a 90% confidence interval. Well, our degree of freedom would then be 5 because we do 6 minus 1. So we'd be looking in this row right here. And 90% confidence would be right here. So our TC value would be this 2.015. All right. And then here our formula is, if you notice, it looks very similar to the other formula that we've used in the past. Instead of ZC, it's TC. Instead of sigma, it's S. But this formula looks exactly the same. We still are finding the margin of error, and the general formula is the same. And then here's a box that breaks it all down again for you. So let's jump back here to this problem. All right, let's find a 99% confidence interval for mean. Well, the first thing we need to know is we have to figure out what the mean, the sample mean and sample standard deviation are. And I'm going to show you how to do that with the TI-84 calculator. So when we are doing mean and standard deviation in here, we have to type in these values. So we're going to go stat and then edit. So notice we have an L1 that's empty. If your L1 is not empty, it's not a big deal. We can fix that. So I'm going to type some numbers in here just to have some in there. If you need to clear your L1, you're going to come up here until you're on L1 itself, push clear, and then push enter. It'll clear them out. That's how you clear one list at a time. But let's type in these values that we had. So we had 45.3, 47.1, 44.2, 46.8, 46.5, 45.5, and 47.6. All right, if you need to continue typing these values, you might pause the video now just to get those values done because we're going to bounce on. All right, to find the standard deviation and mean of our sample, we are going to go to stat, over here to calculate, and we're going to calculate this one variable stat. So you'll push enter, make sure your list is L1, frequency is cleared, and we're going to go to calculate. Right here is our sample mean, this 46.143. And this SX, this is our sample standard deviation, 1.19. And so those are the values that we're going to actually put onto our, let's move back over there, onto our problem here. So we have our X bar is 46.143, and our S is 1.19. It's 1.1900, but I don't need to write all those zeros. Okay, and just we're going to do N is 7 because we do know there are 7 things. All right, now we need to go to our student's T table because now we got to figure out what our margin of error is. Remember our E formula is TC S over square root of N. So we got to find this TC. I'm going to pull this one over here. N is 7. So we go one less than that because remember our degree of freedom is N minus 1. So we're going to look at this top of this pink row. And then we were wanting a 99% confidence interval. Not 99.9, but 99. So our TC is 3.707. So 3.707. We found our S to be 1.19, and our N is 7, so we do square root of 7. So our E is going to be whatever that calculates to be. So 3.707 times 1.19 divided by the square root of 7, and we get 1.67. All right, and then if you recall, our interval is our X bar minus our error, and our X bar plus our error. So our X bar we found to be 46 point, I'm going to go and just round this to a 1 because everything's in 1 decimal above. So I have that minus 1.7 and 46.1 plus 1.7. So 44.4, what was this, 4 centimeters? And 47.8 centimeters. So we can say with 99% confidence that the average height of these miniature horses were somewhere between 44.4 centimeters and 47.8 centimeters, just based on this sample. So if we were to get, once again, if we were to get 100 samples, 99% of the time we would say that the mean falls within this. All right. So let's jump forward here a little bit. So just as kind of a refresher, we got to pay attention to things because we had video 1 talked about what happens if we know sigma, and this video is talking about what if we don't know sigma. So you've got to pay attention to the problem, and do you know sigma or do you not? And then that's going to tell you which error formula you're going to use.